Hey guys, this is Miss Cuban here. In this video I'm going to review or explain how to solve multi-step equations. A multi-step equation could be an equation that takes more than one step to solve. So let's start with review. So a review would be one-step equations. So if I have 2x equals 8. To get x, I'm trying to see 2 times what equals 8. Well, in my mind, if I know my multiplication facts, I know that 2 times 4 is 8. But if I did not know, I could just make and do the inverse operation. So, if I want to do the inverse operation, I know that this is multiplication. So the inverse is division. So I'm going to divide 2 from each side. And I get x equals 4. That's a one-step equation. It took me one step to solve. When I move to two-step equations, a two-step equation would be 2x plus 2 equals 8. And to solve this, I know I ultimately want x by itself. So I'm first going to put a box around my 2x. I cannot divide by 2 unless I get rid of what's happening to the box. So in this case, what's happening is I'm adding 2. So I need to do the inverse operation of addition. The inverse of operation of addition is subtraction. So I'm going to subtract 2. What I do to my left side, I must also do to my right, because I'm talking about an equation. So now I am left with 2x. 2 minus 2 is 0, so that cancels out. And 8 minus 2 is 6. And now I'm back to my one step. So I do the inverse operation of multiplication. I want x by itself. So if it's multiplying by 2, the inverse operation is to divide by 2. So I'm left with x is equal to 3. Okay, so I started with a one step. This is most often done in 6th grade. And in 7th grade, I learned my two-step equations. And so when I go to multi-step for 8th grade, I'm now going to have more than 2 steps. For example, I have x plus 2 is equal to 2x plus 1. I want to know what x is. I don't know right now. So, just like I showed in the 7th grade version, if I'm looking for x, I'm going to put a box around my variables. I have x on both sides. I have 2 boxes. So I'm going to keep my larger box. I like to just have one box. 2 is too confusing. So for me to keep one box, I'm going to keep the larger number. So when I look at this, I know I have an invisible 1, and then I have a 2. Well, I know that 2 is greater than 1. So I want to keep my x's on the right side. I want to keep this 2x. So if I'm going to keep my 2x, then I have to get rid of my 1x. And I'm looking right now at my 1x, and it's positive. So my inverse, my opposite, is a negative 1x. And if I do that on the left, I also have to do that on the right. So when I combine them, I know that I no longer have an x on the left. 1 minus 1 is 0. So I just have 2. And on the right, 2 minus 1 is 1, x plus 1. Now I still need x by itself. And right now it's being added by 1. So I now need to do the inverse operation of what's happening to my x. So the inverse operation of addition is subtraction. So if I'm going to subtract 1 on my right, I'm going to subtract 1 on my left. So now I have x equals 1. So my first step was I combined my x's. Combine them. Get rid of 1. Get rid of one of those boxes. Then my second step was to do the inverse operation to the box. And my last step was to get x by itself. In this case, it was already by itself. So that's how I know I was done. I'm going to use this same philosophy right here in a more challenging problem. So in this problem, I have 1/7 x minus 6 equals 3/7 x plus 4. I'm going to do my same philosophy. I'm going to square my x's, and I'm going to combine them. I only want one x. I only want one box. So when I look at this problem, I have 1/7 and 3/7. They have the same denominator, so I'm going to compare my numerators. 3 is larger than 1, so I'm going to keep the 1 on the right. I'm going to get rid of the left. So the opposite of positive 1/7 is negative 1/7. And remember, a negative is the same as subtraction. Adding a negative is the same as subtracting. So my 1/7 is gone. I now have negative 6. And I look, since they have the same denominator, I can just subtract the numerators. 3 minus 1 is 2. My x plus 4. I'm not done with my box because I still have a plus 4. So I need to do the inverse. So instead of adding 4 now, I'm going to subtract 4. So at this point, I have negative 6 and a negative 4 gives me a negative 10. Negative 6, 2, 3, 4, 5, 6, and 4 negatives gives me negative 10. 2/7 x, and my 4's are gone. So now my last step says get x by itself. So what's happening to x at this time is it's multiplying by 2/7. So I need to do the inverse of the fraction. Well, an inverse of the fraction is to do a reciprocal. So instead of multiplying by 2/7, I'm going to multiply by 7/2 to both sides. I'm going to do the reciprocal. The 7's cancel out, the 2's cancel out, so I'm just left with x. And on my left side, I can put it over 1 and multiply. 7 times negative 10 is negative 70. 2 times 1 is 2. And simplify. Negative 70 divide by 2 is a negative 35. And I am done. Okay, so I want you to go back, look through this, create maybe one or two equations, and you follow the same steps. In summary, I combine my x's, I then do my inverse operation to get x on one side, and then lastly I get x by itself. Okay, hope this helps. Later, guys.